We're given 4 points, O, A, B, C, and then we're given their vectors, which are in terms of u and v, where u and v are non-parallel vectors. We're told that m is the midpoint of OA, and n is along the line AB, such that AN to NB is a 1:2 ratio. So let's draw that out to begin with. So let's say here is our origin. We have A in a random point over here, and let's just say B is over here. So no reasons I picked these particular points in this particular orientation. And then we're told that m is the midpoint of OA, so m would be over here, and then n is splitting AB in a ratio of 1:2, so n would be over here somewhere. It would be about a third of the way along, so this would be 1:2 ratio. N would be about a third of the way along from A to B. So we're trying to work out to begin with what is OM and ON. So let's start with OM. OM is simply going to be half of OA. So that would just be, if OA is 6u minus 4v, it will be a half of 6u minus 4v. And that would then be 3u minus 2v. For ON, so to work out what ON is, we can go from O to A, and then from A to N, but we don't know what A to N is right now, so let's work out that. A to N, if we see what line it's on the line AB, and it's a third of the way along, so N is a third of the way along, so A to N would then be a third of AB, and A to B, we can work that out. That would be A to O plus O to B. So we go in this direction around from A to B. And we have O to A and O to B. So we can rewrite this as negative O to A. We have that vector. And then add O to B afterwards, which we also have. So then replacing these things, so minus 6u minus 4v plus O to B, which is plus 3u minus v. So let's expand this out and simplify. We can now group together the u's and the v's, and this becomes minus 3u plus 3v. So that's what AB is equal to, so maybe I'll put that over here, so we can refer to that later if we need to. And then so A to N would then be a third of minus 3u plus 3v, which is then going to be minus u plus v. So then putting that into ON, ON is then OA, which remember was 6u minus 4v. And then we add AN, which we got as minus u plus v. So I'm going to change this plus into a minus, so it'll be minus u plus v. And then simplify 5u minus 3v. So we have ON as well now. For part B, we're trying to show that C, M, and N are collinear. Collinear means that they're on the same straight line. So it could be like C, M, and N are all on one single line, like this. And to show that this is the case, we have to pick any two pairs of points from these 3 points. So I could pick, for instance, C to M, and I could pick M to N. And if we can show that these two things are parallel to one another, parallel meaning that they will be scalar multiples of one another, then that would mean that as they share a point in common, and because they're parallel, they must be on the same straight line. So as you can see from what I have here, if they're on the same straight line, then C to M should be parallel to M to N. And as these two vectors share this point M in common, then all 3 of them must lie on the same straight line. So why do these two vectors have to share a point in common? So let's think of a scenario where we have 2 vectors, let's say C to A. So these are now random letters not really associated with the question. Let's say we have a vector C to A, and let's say that this is a scalar multiple of the vector M to N. So that means that C to A and M to N are parallel to one another because they are a scalar multiple of each other. But that doesn't mean that these two or these 4 points are all on the same straight line. We could have a scenario where this represents the vector that takes us from point C to A, and then this represents the vector that takes us from M to N. So we can see from the diagram that the two vectors are parallel, but because they don't share a point in common, they wouldn't necessarily be on the same straight line. If this A were instead M, then that would mean that this section here would have to be over here. Okay, so let's work out what Cm is, and let's work out what Cn is. So to work out C to M, we can go from C to O, and then from O to M. C to O is the negative of O to C, so negative of O to C plus O to M. O to M we worked out in the previous part was 3u minus 2v. This is then the negative of OC, which is negative v plus 3u, and then plus OM, which was here. So that's 3u minus 2v, and then simplify this, we get minus 3v plus 6u. Now for m to n, so m to n is m to the origin plus o to n. I've picked those two because we have them. We have what m to o is, it's the negative of this, and then we have what o to n is as well. So then this is equal to the negative of o to m, which is minus 3u plus 2v, and then add o to n, which was 5u minus 3v, and this will end up being 2u minus v. And if we look at these two vectors, Cm and Mn, we can see that if we multiply this by 3, we end up with Cm. So 2 times 3 changes the 2u into 6u, minus v times 3 gives you minus 3v. So we can say, as C to M is equal to 3 lots of m to n, that means that Cm is parallel to Mn, and as they share a point in common, they must be, the 3 points Cm and N must be collinear.